Cambridge IGCSE 0625 October November 2024 Paper 41. Question 1. A spring is suspended from a clamp. Figure 1.1 shows a pointer attached to the lower end of the spring. A student suspends load of different weights from the spring and records the reading on the meter ruler. Figure 1.2 is the reading weight graph that the student obtained. So we can see the reading which is in centimeter versus the weight. Part A. Using figure 1.2, determine the reading on the meter ruler when no weight is attached to the spring. No weight is attached to the spring means weight must be 0. So we are provided the weight on x-axis. So we can find when weight is 0 at this point, weight is 0. What is the value of reading? That is this particular point. So here each small box represent 2. Therefore, this point is exactly in between 42 and 44. Therefore, this reading is 43 centimeter. So we can write it is 43 centimeter. Question 2. A weight of 5.6 Newton is attached to the spring. So we need to find out when the weight is 5.6 Newton. So we can find that point. On x-axis, each small box represent 1.1. So 5.6 is 5.1, 5.2, 5.3, 5. So this point represent 5.6. That corresponding reading we can find using the help of a ruler. So we will get it is 63 centimeter. Hence we can write it 63 centimeter. Part 2. Calculate the extension of the spring when the weight attached is 5.6 Newton. In order to calculate the extension, we can use the equation. Extension is new length minus original length, where new length is the length of the spring when 5.6 Newton weight is attached, and that we already have in the previous section, that is 63 centimeter. And the original length is nothing but the length of the spring when the weight was 0 Newton. That is also we have already calculated in the first section, that is 43 centimeter. Therefore, the difference is 20 centimeter. Hence, the extension is 20 centimeter. Part B. Using the values found in A, calculate spring constant of the spring. So, we need to calculate spring constant K. We already have the force and extension. The force is already given in the question, that is 5.6 Newton, and the corresponding extension we have already calculated in the first section, that is 20 centimeter. We need to calculate spring constant K. Here we can use Hooke's law equation, that is F is equal to Kx. In order to calculate spring constant K, we can make K as the subject. So the equation will become K equal to force over extension, where force is 5.6 divided by extension is 20. Then the answer is 0.28 Newton over centimeter. So the spring constant is 0.28 Newton over centimeter. We can get the unit from the equation, that spring constant K is force over extension. So we just need to write the unit of force, that is Newton, over extension unit is centimeter. Part C. An object of mass 0.50 kilogram is attached to the spring. Calculate the weight of the spring. So here we need to calculate weight. Mass is provided. Hence we can find the weight, that is weight is equal to mass times gravitational field strength, where mass is 0.50 times 9.8, which is written at the first page of the question paper. Hence the answer you will get 4.9 Newton. The weight is 4.9 Newton. Part 2. The object is pulled downwards until the tension in the spring is 6.5 Newton. The object is released. Calculate the acceleration of the object immediately after it is released. So, the moment when the object is released, we can check what are the forces acting on the spring. we have the spring. When the object is released, that point the forces acting on the object is nothing but the weight of the object that will always act downward, that we have already calculated 4.9 Newton, and there will be an upward force, that is tension acting on the spring as mentioned in the question, and the direction of tension is upward, and the tension is 6.5 Newton. So we can see actually there are two forces acting, the downward force, that is the weight of the object, and the tension on the spring, that is upward force. So we need to calculate net force, that is 6.5 minus 4.9 Newton. And the answer is 1.6 Newton. So the net force acting on the spring is 1.6 Newton. Now we can calculate the acceleration using the equation. The net force acting on the spring is equal to mass times acceleration. So we need to find the acceleration. So we can make acceleration as the subject. So we will get acceleration is equal to the net force acting on the spring divided by mass. The net force we have already calculated, 1.6 over mass is given, that is 0.50. And the answer is 3.2, the unit of acceleration, meter per second square. You have to be careful that when you use F is equal to ma equation, you should always check what is the actual resultant force or net force acting on that object. You should always take the net force when you calculate this equation.